Hi, and welcome to WD. Here we do maths. This is probably my first video, so sort of like a proper intro, I guess. I'm Dhruv. You can call me Dhruv. I'm an undergraduate at IIT Kharagpur. Currently in my sophomore year. I'm going to my sophomore year. Yeah, in this channel we do calculus, linear algebra, abstract algebra, number theory. With that said, in this video we'll discuss matrices. So what are matrices? Before that, I need to introduce a small concept called a field, right? So what is a field? It's basically a set of numbers that are united. So first on the addition, what does it mean? Let's take two elements, x plus y, it should be equals to y plus x. That is commutative property. If say my x plus x some c, and that c should also be present in the field. If not, it's not closed under addition. Right? And then we have x into y, same two elements, should be equals to y into x. This condition is satisfied, it's called commutative under multiplication equation, right? Say this is some p, this p should also, for all non-zero x and y, for of course non-zero p, should also be in our set. If so, it is closed under multiplication. And this distributive property, what is distributive property? So it's something different, right? It's nothing different, it's based on the measure. X into y plus z should be equals to x into y plus x into z. Well, these conditions are satisfied, and under these two operations plus multiplication, those set of numbers are called a field. With that said, yes, we can move on to the definition of a matrix defined matrix. We have a field F and two positive real numbers m and n. And we say m cross n matrix. So that kind of triangular array of elements aij such that aij belongs to a field. Right? This is the definition of a matrix. Is how we define what is a rectangular array now. Now, the weird term here is the rectangular array. What is that? And what is this AIG? An array is basically a list of elements, right? List. It's just list. We have A, B, C, D, some list, some elements, and it makes a list. That's an array. So we represent a matrix instead of these two brackets, or you can use these two square brackets or the usual brackets, and it's with m and n to n cross n, or we can call it m by n. It's cross or by, it's up to you. It's not nothing big. So that basically means, what is m here? M is basically, it's a combination of the rows and columns. That's what's a rectangular array. It's combination of the rows and columns, right? That is a rectangular array. It kind of looks like another triangle with few elements, and element has an element in particular. And that element is called aij, depending on which row and which column you place that element in. So general notation is we say I for row and j for column. And basically define the I the row and j column, right? If I'm going to name, so it is m cross n. When you say m cross n, the first number, the m represents the number of rows. Right? So 1, 2, 3 goes on till m. 1, 2, 3, and the next one represents the number of columns. That's n. And so the first element will be A11, Aij, right? Second element will be A12, and then goes on till A1n. And A21, A22, so on to A21. And this goes on to AN1, AN3, goes on to ANN. In M cross N matrix, we have M multiplied with N elements. Exactly. So that's a matrix. So what do we do with a matrix? Why do we need a matrix? So the matrix basically assigned as a form of, for solving linear equations. So they basically arise like this, all right? The x is equals to c. And they are matrices. A basically represents this A1, A2 matrix, right? Something like this. A1, A2, B1, right? And X is X1, X2. C is C1, C2, right? This multiplies cross multiplication. This is not your usual, it's not your usual multiplication, just this multiplication, this normal multiplication that it is different, which we will cover in later videos, right? So that's how matrix arises. And they help us solve these equations in a pretty quick or easy way, right? Keep in mind there are many types of matrices, but the ones I'm going to discuss here is just the common ones, right? So one would be a square matrix, null matrix, row matrix, column matrix. These are just few examples and the ones that are like crucial, very important, etc. So a square matrix, as the name suggests, the width are basically same, which means m is equals to n. It has same number of rows and same number of columns, right? And a null matrix is when all the elements of that matrix is zero. So I can write Aij is equals to zero, right? A row matrix is when you have only one row, which m is equals to one. And a column matrix is when you have only one column. That's metric of matrices. Have few properties, right? We have, we can do addition, we can add two matrices, right? It is A1, A2, A3, A4. This is a 2 by 2 matrix. We can write plus B1, B3, B3, B4. I'm using 2 by 2 because it's simple, but can apply for all of this. And write this as A1, B1, B3 plus B3, B2 plus B2, B4 plus B3, right? This is again a 2 by 2 matrix. And keep in mind, you can only add linear dimensions class, right? The dimensions of the matrix should be the same numbers, and you add the corresponding elements and get the corresponding matrix. Not when they're different. And then there's scalar multiplication. K multiplied with 3. So K times A1, A2, A3, A4. 2 by 2 matrix, yeah? Should give us K1, K3, K3, K4. Right? And let's now look at few properties. These are like few arithmetics, and then there's cross multiplication, which we will do in further class. Few properties, right? Few properties of matrices. A plus B plus C. And whenever I write this can be written as A plus B and then plus C. What this essentially means is we add B plus C first and then add it and we add the result with A. Here we add A plus B and then add the result with C. So what does this equality mean, right? No matter how, in which order you do the addition, you still get the same thing. That means take this to be some D, and this D will be the same. Final matrix would still be the same for these two expressions. That's associative property, right? You can have K, this can be written as KB plus KC, right? Also have commutative property A plus B is equals to B plus A. It doesn't matter which order you add them, you still end up with the same matrix. And then there's another property, which distributive property for matrices. With this, right? This is multiplied by A plus B. And this multiplication is vector, not vector, it's matrix multiplication. A dot B plus A dot C is equals to like adding them and multiplying with that. Those are for matrix. Trust me on this one, it's very interesting. So we have, I'm going to take a general example here, 1, 2, 2, 1, 2, 1, 2, 8, 1, yeah, 1, 2, 2, 1, this 1, 2, 3, 1, and 1, 2, 2, this 1, 2, 2, 1, same yada yada, 8 and 9, 8 and 2, right? This 1, 2, 3, same yada yada, M cross N matrix, so matrix A. So A transpose, we represent a transpose of the matrix. We put a theta on top of the matrix, A1, 1, A2, 1, A1, 1, A1, 2, A2, 2, A2, 2, AN, 2, AN, 2, and this is AN, 1. I'm sorry. And this goes on to AN3, and A1, and then A2N goes on to ANN. Right? It will flip its n cross n matrix. But what change? What Transpose essentially means is that we transform the rows into columns, right? Or so we have the rows and have columns. So we transform these rows into columns and columns into rows. And this is a row, right? This is a column, right? And this becomes a row. A1, A2, and that becomes a row. This is another column and that becomes a row. And we do that until you get all the columns into rows. That's a transpose, right? But if you look at that, the elements like 1, 1, 2, 2, that don't change. So if I have some element with I, it doesn't change because it's basically in the ith row and ith column. And even if you transpose it, it's still going to be in the ith row and ith column. But your A21 becomes A12 and A12 becomes A21, and that IJ becomes AJ1, JI, right? Important thing. There are cases when your matrix and your transpose matrix is the same, symmetric matrix. If you think about it, it has to be a square matrix. And why? Well, it's up to you to think. You can always leave it in the comment. It would be negative of the transpose. And keep in mind, minus here is just scalar multiplication of -1 to the matrix, right? And we call this to be skew-symmetric. Skew is basically a synonym for anti or opposite, and that's kind of the basics of matrices. In the next video, we might actually cover like matrix multiplication, system multiplication. Sorry, I will not in the next video. I'll probably do it. So that's pretty much about this video. Thank you for watching, and always all doubts are welcome.